So in this example, what they have is a new car that sells for $18,000, depreciates 25% each year for 4 years. So Josh, when we're looking at this, the other Josh, therefore, we look at this, we have this formula. And this is our formula that we represented for modeling, correct? And for modeling, what we said was A of t represent the amount after t values, or t time periods. A represented our initial amount. R represented our rate. And t represent our interest rate. And t represent our time periods. All right? So it says a new car that sells for $18,000 depreciates 25% each year for 4 years. Find the amount after the specified time. So what exactly are we looking for? They say find the value or the amount after a specified time. So we're looking for an amount. The only two amounts were initial amount and amount after t periods. So which amount are we looking for? The A of t or the initial? We're looking for the A of t. They want to know. So therefore, in reality, we're looking for, how much this car is going to be worth, right, after 4 years of depreciation, correct? So the next thing is we want to look at the initial amount. So what would be the initial amount of the car? Well, it says a new car sells for $18,000. So that'd be like year one would be $18,000, right? So that is your initial amount. Now we look at this as far as a depreciation of 25%. So if something depreciates 25%, is that going to be depreciates? Is that going to be growing or declining? Declining, right? Depreciation is declining. So therefore, are we going to have a growth equation or a decay? Decay. So therefore, we know that this b, this b in there. In your notes, we talked about b has to be less than 1, correct? Right? It has to be less than 1. So we can't add. That's not going to make sense, right? Because then you add 1 plus 0.25. That's 1.25. That's going to produce a growth equation, right? So we can represent it as a decrease as negative 0.25. It's still going to give us a decimal, but that decimal is going to be less than 1. And then it says after 4 years. So now I can just use So now I just go through my calculator, and I just do 0.75 raised to the 4th power, and then I multiply that times 18,000. And I get 5,695. So therefore, if this car depreciates 25% every year for 4 years, the car is now going to be only worth $5,695. It's a big depreciation, right? It's pretty heavy. 25% every year is quite a bit. I don't think cars depreciate at that rate. But